All right, folks, welcome back. Today, before we start anything, why don't you do a quick review, pause the video, do a quick review of the following 6 characteristics of minerals that we learned about yesterday. Okay, so you go ahead and pause it. I'm going to count on you, and we'll meet back here in a minute. Okay, we're back. All right, the first of these properties today, which we're going to focus on, has a little bit to do with density, which you're all familiar with. And that's specific gravity. This is the ratio of the density of a mineral compared to the density of water. And you all know that the density of pure water is 1 gram per centimeter cubed, cubic centimeter. And if a mineral had a specific gravity of 3, the density of the mineral would also be 3 grams per centimeter cubed. But you notice the specific gravity doesn't have a unit after it. Well, let's see what's going on here. So the first, according to the definition, first number on top is the density of the mineral. Second number in the denominator spot is the density of water with units. But according to specific gravity, those units cancel out. So really, specific gravity is like density, but no units. You guys got that? It's like density, but no units. And it's pretty useful for finding out the identification of certain minerals. For instance, you could find the specific gravity of pyrite and compare it to the specific gravity of gold, and you'd see that, of course, gold has a much higher specific gravity. Okay, moving on. In the reference tables, they do mention one mineral here, very dense. They don't call it specific gravity here, but it's the same idea, 7.6 grams per centimeter cube. And galena is a very dense mineral because it has lead, Pb, in it. You'll see that in lab class. Okay, the next special property, which are distinguishing characteristics of minerals, is halite. It's a salty tasting mineral. You'll try this in lab class. You don't want to actually taste the mineral. Get the mineral wet under the sink, and then just, if you think it's halite, touch it with your finger, get your finger moist with it, and then just, taste your finger. It's not quite as gross that way. And you'll notice right away if it's halite. Okay, the second special property here is magnetism. Minerals like magnetite exhibit magnetic properties. They will attract magnets, and some of them, like lodestone, a form of magnetite, will actually act as a magnet, used in old compasses. Third special property is double refraction. This is an example of Icelandic spar calcite, which exhibits double refraction. It splits images into 2 parallel beams. So you can see in that picture there, the photograph, it says calcite. It's just kind of placed in front of the printed word calcite, and it splits it into another word, calcite. And we're going to try this in the classroom in a few moments. You'll actually be able to see whatever you put underneath it will turn into 2 images. Okay, the next property is fluorescence. Fluorescent minerals will glow different colors, some of them very pretty, under an ultraviolet light. Now, we don't have a really good ultraviolet light here. We have a black light, which works okay. And we're going to do that as well after the lesson. Phosphorescence is different than fluorescence. Phosphorescence you can think of as glow in the dark. First, you got to charge it up with an ultraviolet light, and then it emits visible light after the light has been switched off. So fluorescence, got to have the light on the whole time. Phosphorescence, you can charge it up, turn the light off, and it glows in the dark for a little bit. These are special properties that most minerals don't have, but some do. All right, the last special property, which we're going to try in lab class, is hydrochloric acid placed on a clean surface of calcite will bubble carbon dioxide gas. The chemical reaction releases this from the mineral. The mineral is dissolved in the meanwhile. It actually eats away at the mineral, if you want to think of it that way. All carbonates react with hydrochloric acid by fizzing or bubbling and releasing carbon dioxide. And some of these special properties are mentioned on your reference tables. You can see the salty taste for halite, magnetic for magnetite, and the bubbling in acid with both calcite and dolomite. Dolomite doesn't do it quite as strongly. You have to kind of put dolomite on a streak plate and streak it a little bit, get it into powdered form, and then it will bubble, but not as strongly as calcite. they both have the element calcium in them, which is why they react with hydrochloric acid. Okay, so hopefully you learned something. Now we're going to practice some of these demonstrations now.